In example 6.5, we're being asked to define a linear function that passes through 3, 5, and 8, 15. So when it asks us to pass through, and then it gives us these values, these are to be interpreted as ordered pairs, here and here, which means this is an x value, that's a y value, this is an x value, and that's a y value. So typically when we have multiple ordered pairs and we have multiple x's and y's, it's easier to keep track of them if we label them using subscripts. So I'll call this x1 and y1, and these will be x2 and y2. So for the definition of the linear function, I need to focus really on the equation. I already know that the domain will be all real numbers, but I need to figure out the equation y equals mx plus b. So I really need to know what is m and what is b. Now when you look at the two ordered pair that you're provided with, 3, 5 is going to be in the first quadrant, which means it's not a y-intercept. 8, 15 can also be found in the first quadrant, not a y-intercept. So we don't immediately get b for free. And it also doesn't spell out what the slope is supposed to be either. So we're going to have to calculate both of these items, and then we can get a better idea of what the equation will look like. We're going to start with the slope calculation. For the slope definition, there is a formula that says slope can be interpreted as y2 minus y1 divided by x2 minus x1. Since we've already labeled the ordered pairs with the x1, y1, x2, y2, then we can go ahead and substitute those values in. 15 minus 5, all divided by 8 minus 3. So that gives me a 10 for the change in y and 5 for the change in x. Now we would want to reduce this ratio as much as we possibly can, and it would reduce to be 2 over 1. But in the equation, we typically write it in its simplest form, which would just be the integer 2. So now I can come over here to my equation and write it as y equals 2x plus b. So I still don't know the value of b. However, I can use one of the ordered pair that I'm given as a solution to the equation. Since both of these points are going to have to be a part of the equation, they must satisfy as a solution of the equation. So I'm going to pick the first point, and I'm going to say, let's let x be 3, and we'll let y be equal to 5. Then when that happens, my equation now says 5 equals 2 times 3 plus b. So therefore 5 is equal to 6 plus b. Therefore negative 1 is equal to b. So now I can go back and I can better write my equation as y equals 2x minus 1. So I keep the same slope, and then I put in the new value for b, and that's the equation. We know the domain, so let's write the function definition. F from R to R given by f of x is equal to 2x minus 1. And that is our linear function that passes through the point 3, 5 and also through the point 8, 15.